Yes, dear students, in this video I will tell you about moving coil galvanometer. In fact, students are very much confused, and even we people also are unable to give correct explanation of galvanometer. There are different diagram of galvanometer. Here I have shown in this figure 1 the diagram of galvanometer, which consists of north pole, south pole, concave shape of pole. In the region of these poles, a rectangular coil of conducting wire having many turns, which is wound around soft iron core. It is wound around soft iron core. This is core, cylindrical core. Around the cylindrical core without touching it. Actually, it is difficult to show here. If this is cylindrical core, the wire is at one place, not all around. It is always at one. एक रेक्टेंगल बनता है यहाँ पर ऐसे, हैविंग मैनी टर्न, एक ही जगह, नॉट ऑल अराउंड के इशारे में पड़ना, विदाउट टचिंग इट, वो दिखा हमने, विदाउट टचिंग इट, एंड दिस कोयल इज सस्पेंडेड थ्रू ए थिन स्ट्रिप और वायर of force goes through. It is a conductor, alloy of it has one property, special property. After elastic effect, you might have noted in chapter of elasticity. Actually, when we twist some or give any deformation and release the deforming forces, then body return back to original condition without taking any some time is taken, but it return back without any deformation. That is called after elastic effect. वो इसका सबसे कम है. Now this coil is connected here to a spring, and these are two terminals. In one our book NCR diagram, the scale is shown here, but in fact that galvanometer which you use in lab has other configuration, but main thing are that. So galvanometer consists of a rectangular coil which is wound around soft iron core, and this is suspended in a magnetic field produced by concave shape north pole, south pole. Why the poles are taking concave? Why this cylinder is taking core is taking cylindrical and the core rectangular? There is reason for this. I will just tell you. The other end connected is spring and this terminal T2 where current connect करने के लिए. Actually, you know what is the working principle of galvanometer? When a current carrying conductor is suspended in magnetic field, it experiences torque, which is equal to NBI A sin theta, and the number term B magnetic field, I current, and theta is the angle between dipole moment, meaning normal to the plane and magnetic field. If this torque will rotate, twist the coil, but if theta changes, then torque changes. And if theta becomes 0, means dipole moment will become parallel to field, then torque becomes 0 and it will not give any deflection. This will not give any deflection. So to avoid that situation, we make the field to make theta always 90 degree, means plane of loop remain parallel to field line. We make this system, and the magnetic field in which plane of loop B, in which B means magnetic field, in which plane of loop remains always parallel to mandible B. No, sorry. In which the plane of blue, the mandible B, in which plane of blue remain parallel to mandible is called radial mandible. Radial mandible. Radial. This question generally asked in the exam. What is radial field? Actually, I will write all these things by explaining after action diagram. So, how the field remain radial? People tell something other way. I tell this thing. The concave shape of pole, cylindrical core, and rectangular coil together make a field radial. In this configuration, normal to plane of blue remain parallel to the perpendicular field, or plane of blue remain parallel. So here, this is the shape of pole, south pole, north pole. We have shown cross-section area of cylindrical core. Here field line like this, but they pass through the soap iron and get concentrated. And this remains, this one, this is this one, this is this one. But when we place the coil, this is plane of coil. When it rotates, suppose it rotates like this. So these field line remain parallel. If further rotates, these field line remain parallel. So magnetic field line remain parallel, so that due to those field line experience maximum torque, and then torque will be theta 90 NBA into I. This torque rotate the coil, and due to rotation of coil, this spring connected here get twisted, and this twist in the coil spring, this twist produced by the rotation of loop produce a restoring torque. Means coil rotate this way, it opposes that, and that torque, you know, is equal to C theta. C को कहते हैं restoring torque per unit angle of twist. Or also called as torsional constant. Torsional C. C is called, this C here is called restoring torque per unit angle of twist. Twist means atom, or torsional constant. Of the spring. So these two torques, this torque try to rotate the coil and produce a twist in the spring. When they balance each other, the rotation stops, and then we write C theta equal to NBIA, NBA into I, or theta equal to NBA upon C into I. For a given galvanometer, number of turn of the loop constant, B fixed, area fixed, C of the spring fixed. So this thing constant we write theta equal to, or we write it as theta equal to Ki, where K is equal to NBA upon C, and K is called this K is called here current sensitivity. Current sensitivity. Theta proportional to, so theta proportional to I. So larger the current, measure greater the deflection. So by measuring deflection, we can find the current. We can measure the current. So this is the working principle of galvanometer. This figure 2 shows radial field, radial magnetic field, radial magnetic field. Why do we require radial field? I told you that theta should remain 90, so torque is maximum. And when we pass current, deflection should come proportional to current, as it has come here. You can see the diagram in different books. Different books have different diagrams, but I make this diagram just to make it clear how this field is radial. This figure shows cross section when we looking through downward. So this is cross section of the cylinder. ऊपर से देखें हम. These are north pole, south pole. So what provides, make the field radial? The concave shape of pole, cylindrical core, rectangular coil of insulated wire make radial magnetic field. In radial magnetic field, torque produced by current passing through this is NB tau equal to NBIA, theta 90, sin 91, and that torque produced rotation in the coil. That rotation of coil produced twist in the spring. The spring applies restoring torque, which is called also counter torque, which is given by tau equal to C theta, tau equal to C theta, और C का हमने क्या नाम दिया? Restoring torque. In some book they write it K. Torsional constant. I use K here to represent current sensitivity. What is current sensitivity? Further you may be asked. So K equal to theta upon I. So current sensitivity of galvanometer is the deflection per unit current. Is the deflection per unit current, and its unit is per ampere, because theta angle is dimensionless. So unit of K is per ampere. Question is asked in board exam, what is current sensitivity? Define current sensitivity. It is the deflection per unit current shown by galvanometer. How to make current sensitivity higher? If it's smaller the value, larger deflection, then it will show higher current sensitivity. So current sensitivity depends on number of turns, B, area, and C. So we generally, if we want to increase current sensitivity, so we increase number of turns of the coil. Now, if R is the resistance, I think I can rub now the diagram. So, if capital R be the resistance of the coil of galvanometer, then potential difference V across the coil of galvanometer. V equal to IR, but I equal to what? C theta equal to NBA into I, so I equal to C theta upon NBA. So here V equal to C theta upon NBA into R. From here, what is theta? NBA upon CR into V. So larger the potential difference, greater the deflection. So here we can write theta equal to, I write here KV into V, suffix V. Here KV equal to NBA upon CR, and KV is called voltage sensitivity. Of galvanometer. Theta equal to, I am writing here K into V, or KV that other way, theta upon V. Any voltage sensitivity numerically equal to deflection per unit current. Per unit voltage, sorry. KV is equal to theta upon V. Deflection per unit volt is called current sensitivity. Now one thing very interesting here. Current sensitivity K and BA upon C, and KV equal to NBA upon CR. Therefore, KV upon KR, sorry, K equal to this upon this, and K1 upon R, means KV equal to K by R. Voltage sensitivity KV equal to K by R. So I am explaining here working principle of galvanometer. Now, what the use of galvanometer? We can use this type of galvanometer to measure current, to measure potential difference, or to detect the current. We can detect the current, presence of current also. In laboratory, we use a galvanometer in which scale is shown like this. जो स्केल होता है उसका यहाँ 0 बीच में, यहाँ 10, 20, 30, 10, 20, 30, and this way. Point real. So that give deflection, and that deflection shows that the current or diagonal difference tells that current is going which direction also. So this galvanometer actually can be used to detect the position of the presence of current. It is used to measure the current as well as potential difference. I hope you have got it. Actually, in NCERT book diagram is something different. I will show you in the next video, otherwise it will become longer. And if you want to get the, actually you can read the book. I have explained the symbolic diagram as well as the construction of the galvanometer. The galvanometer simply consists of a large rectangular coil wound over cylindrical core which is suspended or pivoted in the field. Pivoted in the field of North Pole, South Pole magnets, horseshoe magnet. concave shape. Concave shape, rectangular shape, cylindrical core, all together provide radial magnetic field. In radial magnetic field, plane of loop always remain parallel to magnetic field, or normal to the loop remain perpendicular. So theta is 0. So torque will be NBIA. Thank you. See you in next video.